Hello and welcome to the last video lesson of the year, Finding Limits Algebraically. Goal is to be able to solve for limits without a graph or table with values by the algebraic methods of 1. Direct substitution, 2. Factoring, 3. Rationalization, and 4. Resolving a complex fraction. Okay, let's go ahead and start with the first one. We're just going to plug in x and see if that will work. So we've got -3, because it's approaching -3, so we're going to put -3 in for x, so that's x squared minus 3/5 times -3 plus 9. Okay, -3 squared is 9. -3/5 times -3 is positive 9/5. And plus 9. So that's going to be 18 plus 9/5, which 18 is 90 over 5 plus 9 over 5 is equal to 99 over 5. So that means our limit as x approaches -3 of x squared minus 3/5 x plus 9 is equal to 99/5. Okay, as we look at this problem, our limit as x approaches -3 of x squared plus x minus 6 all over x plus 3. Well, if we put in -3 here, we see that gives us a 0 in the denominator. Well, that doesn't answer our question then. So we have to see if we can maybe factor and simplify and then be able to plug the -3 in. So let's factor the numerator. It factors as x plus 3, x minus 2 over x plus 3. Now, we can see that there is a common factor, so we can divide out those common factors, and we just have x minus 2. Well, now we can replace that x with the -3 and get a solution. So that's going to be -3 minus 2, which is equal to -5. Okay, there's the solution. The limit as x approaches -3 of x squared plus x minus 6 all over x plus 3 is equal to -5. Okay, we have another equation. The limit as x approaches 0 of the square root of x plus 1 minus 1 all over x. We notice again if I plug in 0 for x, that's going to give me a no solution. So what we're going to do this time is we're going to multiply by the conjugate of the numerator. So that means I have the square root of x plus 1 minus 1 over x, and I'm going to multiply the top and the bottom by the square root of x plus 1 plus 1. And I do, of course, do that both to the top and the bottom because all I'm going to be doing is multiplying by 1. So I'm not changing the value, I'm just changing the way it looks. Okay, I know on the top that gives me a difference of 2 squares, so that squares the square root of x plus 1, so that means I have x plus 1 minus the 1. Okay, and on the bottom I have x times the square root of x plus 1 plus 1. Okay, now let's plug in our 0. Okay, that gives me on the top, oh, wait a minute. Yeah, on the top that gives me my x over x times the square root of x plus 1. I almost forgot about that common factor that was common in the numerator and the denominator that I need to get rid of. Okay, so I can get rid of this x and I can get rid of this x now. That now leaves me with 1 over the square root of x plus 1 plus 1. Okay, So I now plug in my 0, and I've got 1 over 0 plus 1 plus 1 equals 1 over, well, the square root of 0 plus 1 is 1, so that's 1 plus 1, which is equal to 1/2. So our limit as x approaches 0 of the square root of x plus 1 minus 1 all over x is equal to 1/2. Okay, now we have, as we can see, a complex fraction. So the first thing I want to do is to simplify it. Well, it helps if I can get the numerator into just one fraction instead of two fractions. So I'm going to start with that. So that's going to be 1 over x plus 1 minus x plus 1 over x plus 1. I now have common denominators, and x plus 1 over x plus 1 is still 1, and that's all over x. But now I can start simplifying. Because I distribute the negative, I make this positive, change this sign, change this sign. So that gives me negative x over x plus 1. Okay? And all of that is over x. Now, it's still a complex fraction, so I need to get rid of the complex fraction, so I multiply by the reciprocal of the denominator, which is 1 over x. And that's going to be equal to, well, these are gone. And I notice here that the x's are going to go away also. These x's gone, so now I just need to multiply it out. That's negative 1 over x plus 1. Now I can put my 0 in, and that's going to be equal to negative 1 over 0 plus 1, which equals negative 1. So my limit as x approaches 0 of 1 over x plus 1 minus 1 all over x is negative 1. What happens if you have an infinite limit? Find the greatest exponent of the function, divide the numerator and the denominator by x to the n, simplify, calculate the limit directly. So please pause at this time to copy these all down. Okay, here's our problem. X, the limit of x as it approaches infinity of 4x cubed minus 2x plus 1 all over 5x cubed minus 3. Okay, like we said before, we want to take the highest degree and start dividing everything by that. So that's going to be 4x cubed over x cubed, because that's the highest, minus 2x over x cubed plus 1 over x cubed over 5x cubed over x cubed minus 3 over x cubed. Okay, let's start simplifying things out. The x cubes are going to divide out. This is going to divide out and make this 2, and that's going to stay as 1 over x cubed. The x cubes divide out, and this stays the same. Okay, so that gives me 4. Okay, now if I've got 2 over infinity squared, that's a very, very small number. So this number is going to 0. Same thing with x cubed. It's becoming a very, 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 very small number. So it's approaching 0 also. On the bottom, I have a 5 minus 3 over x cubed. Well, just like in the previous steps, this denominator is going to get very, very small, so this number is going to approach 0. So my answer is going to be 4/5. Okay, I wanted to do this one last example because it's something a little different. Well, we start out by using our function that's given for f of x. F of x equals 2x squared. So we want to get everything that we can in terms of this function. So that means I need to take f of x plus h and plug it into the formula, which would be 2 times x plus h squared. Okay, that's going to give me 2 times x squared plus 2xh plus h squared. And then when I multiply through by the 2, that's 2x squared plus 4xh plus 2h squared. H squared. Okay, now I'm going to go back to my original limit, and wherever I see f of x plus h, I'm going to put in the new equation that I found. So that's going to be, and I'm going to replace f of x with, of course, 2x squared. So that's going to be 2x squared plus 4xh plus 2h squared minus, and now I put in what f of x is, which is 2x squared over h. Okay, now I go through and collect like terms, and I get 4x h plus 2h squared all over h. Okay, well, on the in the numerator I see I can take out a GCF of h, and that leaves me with 4x plus 2h all over h. Okay, the h's divide out, and I'm going to go ahead and move up here to finish this out. That gives me 4x plus 2h. Okay, now I think I'm going to go ahead and put the 0 in there. So that gives me 4x plus 2 times 0. Okay, well, when I simplify that, that means my answer is 4x. So now I know the limit as h approaches 0 of f of x of 8 plus h minus f of x all over h is equal to 4x. Well, that'll do it for this year. Thank you, and I hope you enjoyed the videos. Bye.